Okie doke. Looks like we're here. Looks like we're live. We've got some viewers. Thank you so much for your patience while we're getting it set up. I want to welcome all of you to our label compliance and barcode verification event. We've actually got two speakers today. I'm very excited to announce that. For the first half of this presentation, Jason Mack will be covering some of the label compliance and barcode verification slides through here. And then Dustin Thweet will be pushing us through an extensive walkthrough of the V275 and pulling that information for you. But yeah, that's pretty much it. Does anyone want to pop in and say hi before we get started? Cool. I guess go ahead and just run right through it.
Yeah,
Jason,
no worries. Thanks for the introduction, Matt. Excited to have a quick chat about this. Honestly, with the label compliance regulations that are out there, we're going to be talking about it in the terms of UDI and the medical industry, but these same kind of things are going on across the board for, military and food and, electronics. Everybody has a different version of this. So, everything's pertinent across multiple industries, but really want to talk about what's gone on over the last 10 years with the medical device area. So first, just what is UDI? Then we'll go over a few challenges and then maybe look at a couple pitfalls before we dive into an awesome demo by Dustin, really seeing how verification equipment can help you change the way you handle quality of labels. So first, why did this happen for UDI? Really to get back on the original page on why this exists. With medical devices, they always end up starting at a manufacturer, going through a distributor, and it being used at a hospital, and maybe even having other points along the path there. But in the past, everyone would create their own label and think of the product as their own product the way they wanted to. And when it comes to users, that's impossible for us. We need a specific knowledge of these kind of parts, especially when it comes to health. If anybody's ever seen the idea of like the sales on a mattress, and every single manufacturer has their own part number, so you can never price match mattresses between two sites. That kind of confusion is what was happening in the medical field. And so the FDA stepped in with what's known as UDI. And so in the US, UDI is the name. In other countries, you have the MDR or the NMPA. But ultimately, the idea here is to set some ground rules for everyone to follow so we can meet in the middle and understand exactly how we can label parts and then how we can use those labels out in the field for, the decades or more that some of these medical devices last. So how do you go about doing this? Well, you have to create those guidelines. And what UDI did was they started off with the same idea of what a UPC code is. So a device identifier. It is a generated and assigned static number that every medical device has. That's going to be the first part of any of these UDI codes. The same idea of and then second, much like we have with addresses, you're going to have information about the barcodes that are going to be embedded as well. This could be serial numbers, expiration dates, manufactured dates, anything that you already want to include with your product. There is a format and a specific way that that's going to be able to be included. Now, besides actually, creating that data and organizing it in a very specific way, they are provided on every single label with both machine readable, this would be barcodes and RFID, as well as the human text or human readable data. Both are equally important. If you're talking about recalls and usage in hospitals, obviously that barcode is going to be the thing that is ubiquitous. Think of, again, we talk about grocery stores. You're not going to go to a grocery store and type in numbers anymore. If that product doesn't scan, it's not a product anymore. And same thing is going to be the case for most of the heavy users of these products, any of the logistics movement of the products. The human readable is more information for us as we're users of the product, maybe some point of sale to understand those kind of expiration date information without having to scan it with a machine device. So once you have the information, you have to organize it on a label in a very specific format. And we've been going over this for a number of years, but everyone had their own way of putting data, and it's been a big difficulty. And I know a lot of people have faced this in order to fit all of the information that you deem important through your validation process while still fitting all of the information that's required for UDI. And so, you have a couple different options here, and that's where we show like the 1D code at the top or the 2D code at the bottom on the left label. And then, you can see within the yellow and the green how that data is encoded, looking at first the DI, so that product ID, and then the right, which is all of those, pertinent information for the PIs, so the expiration dates and such. But it's very important that all of this information is in the correct format. It's sized so that you can both produce the label and that you can read the label. And all of that is laid out within the governing bodies. And depending on what part of the process you're looking at, your label may have different requirements. And again, this is the part that I just, this is the dry part, but really wanted to get it. The label is the product. And so whether you're looking at the unit level and needing a lot of that very specific information about the product itself, or you get into case shippers or pallets where we need bigger barcodes that are going to be read by overhead barcode readers in a, automated logistics facility. Each application has its own needs and requirements. And so you really have to make sure you look in the documents of FDA, of GS1, and all the way down into ISO to make sure each of your labels is compliant for that specific category of label. So, how do you know where to look for this? The governing body that created this for the UDI would be the FDA. And they created the GUDID, which is the database where you get assigned these part numbers that you are going to turn into labels. Once you have classified your products with the FDA, which everybody has already done before any of this kicked off, and you have all of your data, then you're going to need a way to encode that data into the label. So there's a couple different options here. You may have heard of GS1 or HIBIC. These are going to be your more popular ones, but they're the ones who basically define what the data structure looks like. And this is very akin to an address. We talked about this a little bit before, but I have to write out an address in a specific format, or it would be very easy to confuse a zip code for a street address or a street name for a street number. We have a format with commas and specific capitalizations of 2-digit state codes in order to make sure that when I send a package, everyone down the line is going to be able to interpret where that needs to go. Same exact thing for GS1 and HIBIC. So it's very important to not only understand how to encode it, but then to have very good handwriting. And that's where the ISO piece comes in. So GS1, besides telling you how to encode the data, says it needs to be compliant to the ISO standards, who are the standards for the printing of barcodes. And this is going to be the handwriting quality. Just because I wrote something, on a letter doesn't mean that everyone is going to be able to read it. The same thing goes for our labels and our barcodes. If a machine can interpret the difference between the lines and the spaces or the location of the dots on the data matrix, then it's not going to be able to read the code and output the correct information. So when we're trying to understand what we have to do in this world, it's ultimately a chain of command here where the FDA says you have to be GS1 or HIBIC compliant. GS1 and HIBIC say you need to be ISO compliant. So when the FDA says all of your labels need to be UDI compliant, it means through this chain of command that every label needs to have a C or better grade or a 2.0 or better grade for ISO in order to be compliant for GS1 and therefore compliant for the FDA. And we'll leave this here for everyone to look at because we'll post this on the website for everyone to download. But this has been going on for a long time. And that's part of why we wanted to kind of come back now that everything has been enacted here on September 24th, 2023, and make sure we all thought about this again, because things might have been done by a team or an employee back in 2014 as this started to kick off. But that may have been just for class 3 devices, and it may not have transferred down to other devices. So it really is the time now that the teeth are in place for the FDA to come after people to really go back and make sure that our entire process is compliant. So when we're looking at what that requirements and compliance means, and we're going to get over this in more detail with Dustin, but it means grading your barcodes. This is going to be your best way to fight against any of these problems, because this is going to be what the whole industry is going to use going forward, just like UPC codes have been so ubiquitous with scanning of groceries now. So not only are you going to need to meet the 15415, 15416, and 29158 requirements of the quality of the code, but you're also going to need to make sure that you have a calibrated process and a validated system, and that your data is being controlled and compliant per CFR 21 Part 11. I know that's a lot to throw out there, but this is the kind of stuff we want to make sure that we can, if someone asks us, if someone goes through the process, that we know. Where lots of people fall off in this case is doing things like just reading the barcodes. Unless you have a process behind that with an offline verifier that's been validated to say that if I can read it in my process, then it's at a higher grade, then there is not that validated process. So we really need to make sure that the barcode side is all checked. And then secondly, if we don't have a machine vision system doing this, we're going to need to have an operator at 200% inspection to actually look at the human readable portion of the label as well, because that is just as important as the barcode. The difference is that humans can actually inspect human readable, whereas a human can't really inspect a barcode accurately. So now that we kind of know what all of that means, we'll go through just a couple of the major errors that we see in the field and people should really keep an eye out for. One is you have to set up the label correct first. And typically where this problem comes in is if historically a different format of data has been used. And so this is where an offline verifier that actually checks the syntax of the GS1 can be a big help. Not only does it break out the data so you can see it in the format here, but it's also going to do some checking and look, in this case, that 021917 probably meant to be encoded as February 19th, 2017. But given that the format of GS1 is year, month, day, the 02 would be the year, so that's 2002. The month is 19, which doesn't exist, and the day is 17. So clearly this, if scanned into a database at a hospital, it would not be able to be understood by that database. And this product would say that it expired, 20 years ago. And so we really need to pay attention to these type of data analysis and data input. And this is where most of the difficulties come in. On top of that, when we're creating these barcodes, because it is an image, and depending on how systems are created, if there is a label management system involved, you may have issues with aspect ratio of the codes. If the image that was used and imported was not opened with the correct programs, you may have degradation of the actual file, which causes issues. And so it really is important to, once you have your system set up, check it with one of these offline verifiers that we'll go over in about 10 minutes, and make sure that your entire label is created good from the start. Now, once it's created, we're going to have to print this nice for, 10 years, 20 years, whatever it is. And maybe that's 1,000 labels a week. Maybe it's 10 labels a week, but it might be 200,000 labels a week. It really varies based on the type of medical device. But the difficulties don't change. In order for these labels to have the longevity they need, you're going to use thermal transfer labels. This means that you have a separate ribbon and a separate label that, when heated, are going to permanently marry to each other. The reason direct thermal, the other technology, isn't used is because you have all of the things you need. If you just apply heat, you can change how the label looks in the field. And, something as simple as friction is going to provide that heat. We can all picture, being able to sign a receipt at a restaurant with our finger, and it looks just like ink because we're applying that friction heat to the label. In this case, having those two different pieces possibly could be mismatched. Very easy for someone over this 10 years since the UDI mandate has come in to have either had a label discontinued, had someone that wanted to save a buck and switched out either the ribbon or the paper without understanding that they need to be married to each other. And then on top of that, you have folds, you have damaged print heads, you have an operator that changes settings without really understanding what they're doing, maybe so that the logo looks really nice, but the label itself is poor. So this is where we need some kind of ongoing support to either 100% inspect or set up a process that's been validated in order to spot check and make sure that we're catching all of these errors. Because again, if we had a product that didn't meet the normal standards, would we want it to make it in the field? Highly doubt it. And once you have these bad codes, which they're going to happen at some point, you're going to want to make sure that you have that system, like we talked about, that's validated to make sure that once audit comes in, that you're going to prove that you did everything you could to stop this from happening. Now, these aren't just homegrown problems. Within the medical device manufacturing world, there's a lot of shared technology and contract manufacturing and relabeling of OEM products. Ultimately, whoever's name is on the box is who's on the hook for these issues. So we really have to make sure that we're checking with our OEMs and our suppliers that we don't find any problems on those labels, because the amount of downtime we've seen can be a very big loss of money. And then on top of that, the brand damage or the recalls that can happen based on poor barcodes is a company killer. And then finally, even if you're able to make sure that no bad labels make it out, ultimately, if something ever does, the ability for the FDA to come in and place injunctions and seizures of products is a real worry. We want to make sure that we have the paperwork to show that we're doing the best we can and that we're not just making assumptions within our process. Any questions at this point, Matt? And then I can give a couple pitfalls here that I've run into in my years of going through this and how they were overcome, and then we can pass it off to Dustin with the equipment.
No questions have popped up so far. I think it's also just always a little bit fun when there's just so much information coming in.
I know, and that's honestly a lot of what we're going over here. The idea is not to become an expert at the end of this. It's to know the questions to ask. Mm-hmm. It's to know when we go out to our manufacturing floor and we ask the questions, is this what's the validated process for grading barcodes? Or, if we have a bad barcode that comes in, how are we going to be able to handle that? Are we saving these records? How do we re-access these records? These are all the questions that we need to ask ourselves about our current process to make sure that we're going to be safe, as this mandate now has, everyone looking at it. Mm-hmm. So we talked about a couple of those potential problems that people have run into. Here are two examples of how medical device manufacturers were able to overcome those. So the first one I touched on, we're looking at a lack of supplier oversight. So this would be a case where a diagnostic instrument manufacturer was getting reagents from an OEM. These reagents ultimately were being relabeled and were not being relabeled. They were being private labeled for the device manufacturer. And the assumption by the company was that all of these labels were meeting the standards. When they looked at the barcodes, they could see that they were printed nicely. They even scanned them with the phone and they scanned fine. But what they didn't ever do is actually look at the data. And what it turned out is, while from the view of an operator that doesn't really understand GS1, the data looked encoded correctly, but actually they put little parts to the code, parentheses where there shouldn't be parentheses. They forgot a function 1 character at the beginning that actually made it not a GS1 code. And if anybody with a system that was designed to scan GS1 codes, which phones are not, you would get the data and it would be incorrect. And so what they started doing is, anytime they signed on a new OEM to private label products for them, they ran them through a process with an offline verifier. In this case, it was R9580. And this would allow both the supplier and the device manufacturer to, know right off the bat that all the labels are correct. And then that would go into a database and be saved off. And anytime a new batch would come in, they would check those. And it was around a 10% error rate. And this was, around 5 years ago when they were running into this, before they introduced the new 9580 offline verification that can check for that. The second one was an internal issue, but it was a globalization issue. So, multinational medical device manufacturer on the instrument side of the world was looking to handle the COVID situation where factories were being shut down and they needed to be significantly more flexible. Especially one thing that COVID taught us is that at any given time, a specific product may have hyper demand. And if we're not set up to be able to handle that hyper demand, then we're going to miss out on business. And so they wanted to be able to take a line that typically ran, let's say, in the United States, and be able to double production by shutting down a line in, let's say Germany or Costa Rica, and continuing to run that line with the same products that were being made in the US. In order to do that, yes, making the products is one thing, but the labeling and the packaging is a whole nother thing that often gets overlooked. And in this case, bad labels were coming in. Even though it was the correct information, they were poorly printed. And, everybody wanted to point fingers. No one was taking responsibility. And ultimately, a inline solution like the V275, which Dustin will demo next, was able to allow a small team that stayed on their main site in the US to manage label creation and label quality globally. They were able to create the templates in a label management system to make sure the data was good. And then they were able to create the inspection templates using the V275 and just push them out to all of their facilities. So it went from something that was difficult and had potential pitfalls and problems to something that they could actually speed up production. So it really allowed them to make these changes without having to worry about whether first systems would come and be incorrect and have to be relabeled. So being able to do that automated sense and drive all of the creation and standardization from one site was a huge boon for them. So just a couple examples. Ultimately, what we've been talking about here is, all of the problems that could go wrong with a label. Ultimately, there's two pieces of equipment that we wanted to show you today. Dustin will start with the V275, and we can talk a little bit about the 9580 if we have time. But these are the inline and offline verifiers that will get you compliant and have all the tools to make compliance easy for UDI. Dustin, if you want to take it away.
Yeah, sure. Thanks, Jason. Hi, everyone. As Matt and Jason both mentioned, my name is Dustin Thweet. I'm an application engineer based on the West Coast for Omron. And I'm one of the product specialists for the V275 and pretty much all the verification products that we offer. So we're just going to do a quick technical demonstration showing the V275, and real quick, we'll talk about exactly what the V275 is. Like Jason mentioned, it's an inline inspection system. That's a print quality inspection system, not just barcode verifications. I mean, this software gives us the capability of not only inspecting the barcodes for GS1 or ISO standards, but also checking for human readable issues and checking also for any defects on the label, things like ribbon wrinkle, dots that misfire on these thermal printers, which is very common. And this is a all-in-one solution that we offer that's actually integrated onto the ZT series printers offered by Zebra. And we have these in a variety of configurations from 600 DPI to 300 DPI, 4-inch and 6-inch units as well. So what we see here on the screen is this is the V275 software. This is the welcome screen. And of course, in this demonstration, we'll be running in simulation. But the great thing about this software is we have the capability of running one software platform for up to 4 units. So if you had multiple printers in a print room, We can connect to all 4 of those inspection systems with one PC, one server, and run that inspection. And there's obviously the server-client relationship where you could have just a server, central server for running all 4 systems, and you could remote in through multiple PCs to the software and run your inspection. So during this inspection, we're gonna go ahead and load up the demo that we have here. For each label design that you would probably have, you would have a template or recipe that's assigned to that label design. So it's unique to each SKU of label that you have. So we'll go ahead and we'll just click on demo, load up the one that we currently have. You see here on the screen now we have our label. This is just obviously a very generic label, 4x4. That we're already inspecting the barcodes that you can see here. That's what we see on the left side of the screen. We have our what we call regions, so regions of interest, ROI, for each code, and we can select these and see the information that's embedded in the code. We can even click on the grade itself, and here's where we see all the grading parameters per the ISO 15416 in this case. And on the 2D, if we click here, we can see for the ISO 15415. And as I mentioned before, we have the ability not only to inspect for ISO, but we could even change and read for the GS1 standards for the tables that you see here on the right. And with the tools across the top, we can see as we're in the Edit tab, this is where we can kind of create our recipe. We can grab other tool sets of the software and design around specific areas that we wanted to see. So in this case, if we wanted to look at the branding of the label, this is very, very popular. We can just simply draw a box around the area. And as soon as we have the region set over here on the right, the options become available for how we can change the sensitivity settings of that given region. So in this case, we have the background, which is represented in this kind of fuchsia color, and the aqua is the foreground. And you can see here where we can change the sensitivity settings. And then, of course, we have the max dimension. This is very important, where we can change how large of a defect we would tolerate. Now, this software is pretty sensitive. We could go down to 5/1000ths of an inch if we wanted. So we'll even zoom in here where we can see all the way down to the minute details of the label. We could essentially pick up dust on a label if we wanted to. That's how good the software is. Now, obviously, that'd be counterproductive to any type of production environment. So we're just going to set this up to around 2/100ths of an inch. So we'll see anything that changes in this area up to 2/100ths of an inch. And what I mean by the blemish tool here is it's essentially what's called an image subtraction tool, where it's going to look for any type of anomaly based on what we consider ideal or golden image. And that's what we see here at the bottom, where we set all our inspection around a label that we deem to be perfect and not have any defects, and we'll build our inspection off of that. Beyond that, it just as we can see here, we have the Verify 1D tool, the Verify 2D tool, blemish detection as we just set here, and then we have OCR and OCV. And Jason touched on these briefly. OCR, optical character recognition, gives us the ability to read human readable print. And then optical character verification gives us the ability to not only read the print, but also check for the print quality and also match that to some data source, whether it be something else on the label like a barcode, or to some file or something where there's a database for something like serialization and so on. So these are really valuable for checking your human readables of like lot numbers, reference numbers, GTINs, things like that. Even matching those to the barcode, as I mentioned earlier. For demonstration, we'll go ahead and we'll select this one, and we're going to put it on this number down here, and we'll check for sequence. So as I zoom in, you can see now the OCR tool is set. It's reading 001. We can even go in and we can train the font to ensure that it says the right thing. We'll just, or we can train it to exact print versus what we see real time. And of course, down here, we have the ability where I mentioned earlier where we can actually match this to something. So in this case, we'll do a sequence where we're going to ensure that this is serialization, that it's going to say 1, 2, 3, 4, 5, 6, and so on all the way up. And if it ever drops out of sequence, we'll catch that. This is a really good feature for, again, things like serial numbers, critical data where we know that it must say what we expect it to say. So with all that being set up, we can go ahead into a test run. So we'll jump right into the run screen. We'll start running, and this is what operators would see during a live run. So we're actually printing real time. Again, we're in simulation, but this is what operators would see. As we're printing these labels, the graphic shows you exactly what is coming out through the printer. And we can see here where label 1 was great. Everything came out fine. Label 2 was good. Label 3 looks great. 4. And then, of course, we got to stop here on 5. Software stops the printer. And again, during a live print, we have the ability to stop the printer, alert the operator through the GUI that there's an error. And then, of course, the operator could make a decision on how they want to proceed. So in this case, we had a 2D code that has failed here. Gives us the quality right here. It says threshold 1.5. We had set that per the ISO standard of a minimum 1.5. This is entirely configurable. If you want only 4.0 code, you could do that as well. And this one failed for 1.0. So we know that that's failed. In this case, we have the ability to accept. This is another configurable permission where we could assign this to an operator or not, where we wouldn't want them to just simply accept it. But for this demonstration, we have that ability. And of course, we also have a blemish defect. So remember when I set up this blemish tool around the Omron branding, there's a slight dot that misfired, and this is a good example of what we see usually, again, when those dots misfire, things like that on thermal printers. We can even zoom in and see where the error occurred. Shows it right here, shows us what it expected to see versus what it actually saw. So in this case, we'll go ahead and we'll say remove the label, and then we can continue printing. So as we continue printing, again, we keep moving along. A few more labels are printed. Everything looks good. The software makes it very easy to identify these defects real time. And again, we have another one that's pretty obvious here, showing what a barcode defect looks like, where the barcode has essentially been squished or truncated. And we can see that here. We can even click here on the actual defect itself, and it shows us, so axial non-uniformity. Again, another one of those parameters for grading 2D codes per the ISO 15415. Again, we'll remove that label. We'll continue printing. And here we go. This is the OCR read where nothing was printed at all, and says, hey, we didn't see anything in this given area. And we can see that here where it doesn't see it or match it to the font library. Again, that's a pretty obvious defect, so we'll go ahead and remove that one. Continue printing. Of course, now it's out of sequence because it says I'm still expecting to see 11, as we can see here, and it didn't see it. So on this one, we'll go ahead and say accept because we have that permission. We say, all right, we know 11 was missing, and we'll continue printing. And again, pretty much everything you see on the software is configurable. I mean, again, it's really about finding what tools work for you as the end user, and then setting up that accordingly. This is a great one. So this is where, again, in this area here, we had a defect occur. We can see 2 here, where this is very common, like a ribbon wrinkle that you would see on a traditional print job. And again, it catches that as a defect. And it also shows the size of the defect. And I think this is important to point out. As we said earlier, we set this to 0.02 inches. A lot of times in label inspection, manual inspection especially, operator A might say that this is okay. Operator B might say it's not okay. This gets rid of that ambiguity that exists sometimes. And also, we've set an actual value for what is passing and what is failing. So no more of that subjectivity between operators. And now we have that threshold that is clearly defined. So again, we'll hit remove label, and we'll probably print a couple more here. Again, this is a good example of maybe something that's printed wrong. In this case, a character that's clearly not a legible character by any means. And of course, because it's looking for a sequence, it says sequence here, that it's out. We'll hit stop run just for a second. We'll go into the log file here, and it's all well and good that we've identified all these errors, but what do we do with them? So obviously we have the ability to stop the printer and alert the operators. In our premium models, we even have the ability to back up and overstrike a label when there's a defect. So it's a more of an automated solution. But we also keep track of every single label that's ever passed through this inspection system. So in this case, I've opened up the log file, and we can see here the time date stamp for the past run. We can see that 17 labels had been run. In this case, it shows each operator. For an end user, typically every operator would have their own username and password, and that would show us who was actually logged in. This is great for traceability. and even what PC it was ran on, and of course the template name. And if I click on this run, we can go in and we can see a nice matrix of every single label, both good and bad, and what passed through. So in this case, we can look and see the embedded information for the 1D code. We can even click here to see all the grades for that code. And we can do this for every region of interest, including the OCR, the blemish, etc. And for the bad ones, we can click here and we see a nice thumbnail of the actual graphic itself, and it shows us what it failed for. Now, beyond that, again, is a lot of times for traceability, you need some type of documentation, and we have summary reports as well. So you can see this is really good for a lot of times when printing labels. You might have a work order, operator might have a work order that tells them to print X number of labels. They print off those labels, and then those labels will go with that work order downstream. This is a nice report that usually will be attached to that work order that can go downstream with the labels, and all the defective labels would also be attached with this, and that could go on to the quality department. So in this case, we look at the summary report. Again, it shows the log name, shows what template was being run, what operator was printing these, the start and stop time. So we see how long they spent printing these, how many labels were good, how many failed. And then we can go down and see a summary of each given region. Again, very useful for traceability. And then even beyond that, we have the repeat report. So if quality would like to have a report of each label that failed to detailed information, we can offer that as well. So in this case, we can click on this particular label, label number 5, see that this label failed, what time it failed. And if we scroll down again, we have the nice thumbnail showing why it failed, and even little detailed information as to what the issue is that we see here. And again, here we can see another example where there was a blemish defect, and it shows what it expected to see versus what it actually saw. And again, gives us that value that's so important for objectivity. And that's essentially it for the V275. As Jason mentioned before, here at Omron, we have a variety of solutions for verification, whether they be offline and inline. We'd be happy to talk about those products another time. Jason, did you have anything you wanted to add?
Yeah, I can show that I have the offline verifier set up
Okay.
since we still have a few minutes here. So
yeah, I'll pass it over to you.
Perfect. So what we're looking at here is the offline verifier. So these are meant to, once you already have a label printed, either because they've been out in the field or because you are trying to set up a printer or a laser marker or whatever it might be. This is going to be your real analytical tool. It can be used spot checking as well, but the real power comes when you have time to really spend time with your code a little bit. So on the first page, you have the option to really set it up for what type of inspection you're doing. You'll see besides the GS1 and the HIBIC, you have just about anything you could think of for regulatory codes here. In this case, I've said that we're in table 1. So you can see all of the number of different tables that exist, as well as telling it not to generate a warning or to generate a warning, but don't change the grade if it's out of spec. Ultimately, what you're doing here is setting up the parameters for which, level of scanning is going to happen to this code. Is it on a case pack? Is it going to be in point of sale? Because it really changes the size and requirements of the code here. So once you have this set up, we can go over to the grading tab, and I have some labels that I've had with me for some time. And you can see on here, we have an A code. As Dustin went over, there's a bunch of different categories, and you can see them right here with details. We can also look down and get even more details than you would get in the inline and actually see our X and Y print growth, meaning are any of the squares or elements here in the code too large or too small for what we're looking at in either direction. Again, which would allow you to make changes on the fly and really set up equipment or check if equipment made it back from the field and had damage. It's got the nice bright green, so an operator that doesn't know anything that's going on is going to be able to look at that and know that it is a quality label. But then we get into the more important things for an offline verifier like this, like being able to use this and zoom in on a code. So now we can start to see what looks like a easily perfect label, while it passes all of the tests, you can tell that maybe the sizing of our printer isn't perfect. Maybe we need this to be more crisp. Maybe we don't. Another important thing that we can see here is we're actually encroaching on our quiet zone on this. So what that is around the outside of a code, you need to have one extra space the size of any of your elements outside here. And so by zooming in here and looking, we can tell that this square is bigger than this space. So when creating this label, the text should actually shift a little bit further right than where it is now. It's not enough to affect our overall grade, but that's something that if we want to make sure that we aren't causing any more problems or don't introduce more problems later, that this is going to give us a little more room for error. You can also see, like we saw with the numbers, there's a little bit of overprinting going on. You can see with this square that it's a little bit bigger with that element than the space next to it. So we're overprinting, meaning we're putting too much ink down than what we need to do. Typically, this could be caused because we're having adherence problems with the labels because they're not matched properly. And so we're having to apply more heat in order to print the label, or the settings have just gone off. The light of the printer, the ambient temperature, all these things can affect our printing. So these are the kind of setup tools that we can use here. Then we can even go one step further and look at a full 2D analysis. And I'll pull this over here on the screen once it's completed. And you can see that this will actually go into every cell here and tell us how we're doing. It's a very nicely printed code. That's why I have it. But you can see that it gives a grade on not just the overall code, but each individual element. Again, if you're not the expert that spent the last 20 years trying to be perfect about knowing why codes are bad, this is going to show you right where that problem is on the code. And if it actually is causing degrade, worse grades on your code, you'll see where it is, and then you can make action to make your changes necessary instead of just hunting and pecking for an answer, trying to print a label and making a change and seeing if it's better. That's not what we want. We want to do more an analytical approach to this. And then we talked about this last piece to close out, but the structure analysis with an offline verifier. So you'll see this, like we talked about, is actually going to break out all that data. When we look at our grading tab, we can see this is what's actually encoded in the barcode. If you were to scan this with your cell phone, this is what it looks like. It's just a string of data. I know we see the parentheses and the printed text, but that's not part of the way you encode this. You do have a function 1 character, which is much like pressing the F1 key on your keyboard in ASCII at the beginning to tell it, hey, I have a formatted code coming up. But the rest of the structure is all just based on where those identifiers are. The 01, the 10, the 17, the 21. It tells us where all of those data breaks are going to be. So again, if you had no idea what setting this up would look like, this is where you have to go to see this. You need a machine to tell you what the machine is reading. So just a quick look at these. I always have one of these with me. You're always welcome to send Dustin or I a label. And we can do a quick analysis for you. We're here to help share our knowledge and make sure, everybody's taken care of. And honestly, especially when it comes to medical, we've heard from lots of customers, and it really kind of warms our hearts that, these regulations are what make sure that, people are getting good products in a timely manner. And, we at Omron do our best to try to be part of that solution out there. So thanks for taking the time to run through all of this with us. If I'm going to leave anybody with anything, please remember your label is your product. So put just as much effort into the quality of the label as you are into the quality of the product you're producing.
Cool. Great advice there. Thanks so much for a fantastic presentation. I'll leave it open for a moment to see if any questions come up in the chat. Yeah, otherwise we can always send out a follow-up email and then send it out to him just kind of connect between the two. Outside of that, if someone wanted to reach out to you directly, what's the best way to do that? Just following up through email?
Yeah, following up through email is perfect. My email, and hopefully Matt can send it out with everything, is jason.mack, M-A-C-K, @omron.com. You can also reach out to Mechatronics, and they can get us over to our team members who can help.
Cool, sounds good. Sending out both of those right there. Feel free to follow up with us on an email, and we'll be able to get your questions answered for you. Outside of that, nothing else coming in. Just a couple of awesome presentations, and thank you so much for your time.
Yeah, you bet, Matt. Thanks so much.
Of course. Yeah, cool. And there we go. Stream is over.